Welcome everybody to this webinar. We're very pleased to welcome you here and talk a little bit about this World Angus Evaluation project that we've been cooking on for a long time. Before we jump into the topic right away and talk about this release that will happen later this week, we wanted to take a step back and talk about this project. And really this World Angus Evaluation project has started with the Food Score initiative. If you will remember back in 2020 that we launched a joint food score genetic evaluation, and that genetic evaluation involved the combination of the data from the American Angus Association, the Canadian Angus Association, and Angus Australia. And so since that point on, and even a little bit before then, we had been investigating what are their traits and doing some research about the possibilities of combining those three databases for other genetic evaluations as well. And so as we'll go through this presentation today, you'll see the World Angus Evaluation will expand to 11 more traits here and Friday, October 13th. So we're very excited about the release. It's been a long time in the making for this project, and we'll cover some of the results and some of the research that's been done on this topic. Why this World Angus Evaluation is so important and is so relevant? Here I wanted to represent this slide, that collaboration that was done with the Food Score evaluation back in 2020. We talk about collaborating and joining the databases, right? And we can see here on this slide where I have the data used in the food angle and the claw set genetic evaluations. And you can see based on the colors here that Angus Australia represents almost 50% of the data in that evaluation. So when we combine those databases, we bring a lot of extra phenotypes. And we talk about phenotypes and how valuable those data are to predicting those EPDs. And so combining those databases is very valuable. It brings a lot of extra data into the evaluation. So in 2020, that what was done for those food score evaluations, both for food angle and claw set. And that at that time would basically double the number of phenotypic records in those genetic evaluations. And as we talk about the motivation for this project, of course, once we saw the benefits of that and the additional data that we're able to add on the food score evaluations, we wanted to explore the opportunity to better describe Angus cattle, right, using phenotypic data on other traits as well. So we think that a project like this has a lot of benefits. We can look into facilitating international commerce and exchange of Angus genetics across the globe. And of course, from a personal standpoint, when we look into the research side of this, it promotes a very big collaboration on the research as well. And so here we're talking about combining the databases, but also the resources from the American Angus Association, the Canadian Angus Association, and Angus Australia. And so it's very exciting when you get all these three groups together to talk about research and discuss new ideas around all these databases that we can combine together. So what's going to happen here on October 13th is we're adding 11 new traits into that World Angus Evaluation environment. Here we have a list of all those traits. And as we look into what are the genetic evaluations that are involved in this process, we're talking about the growth genetic evaluation, where we have the birth weight, weaning weight, yearling weight, and the milk EPDs. Then next we have the Cavinese evaluation with the Cavinese direct and Cavinese maternal EPDs. We have as well the carcass evaluation with the marbling, carcass weight, ribeye area, and fat. Of course, here we're also talking about the ultrasound record, all those ultrasound records that get added into that genetic evaluation. And then we have the scrotal circumference evaluation with the scrotal circumference EPD. As we talk about sharing the data and all this combining of all this data, it's very easy to think about the phenotypic records, the actual measurements that you make on the animals. But when we talk about combining those genetic evaluations, we are also talking about pedigree information, we're talking about genotypes, and this last one that I have here is what I'm calling metadata. But if you think about, we need a lot of additional information to make sure we're able to put together a good contemporary group structure. We need to know sex information on those individuals, how old they are, and also very important to have a list of cross-reference IDs across those databases, because we want to make sure we are uniquely identifying those individuals as we combine those genetic evaluations. One of the things that is interesting and that we'll see a practical change in here is that when we look up an animal today on the AAA side, You can see the EPDs of that individual. You can see the accuracy, percentile ranking, but we can also see a progeny count on those individuals. And so once we release the World Angus Evaluation, if that particular individual has added progeny from Angus Australia, you'll be able to see that count go up, as well as potentially an increase in accuracy of those EPDs because of the additional data that we're adding. I think one of the things that's very exciting about this project is we're combining all this data, and the American Angus Association serves as a host for the World Angus Evaluation, and so we're combining all the data here, and of course we're running the genetic evaluations here as well. And so nowadays, for example, we get for the weekly genetic evaluation, we get data from the American Angus Association's database on a weekly basis, and then we'll get extracts from the Angus Australian Association on a bi-weekly basis. And then from Canadian Angus Association, we get extracts on a monthly basis. So that means we're getting the new data from Canadian Angus Association every month. Of course, I think it's important to mention here, the Canadian Angus Association's data has been together with our evaluation in that joint environment for a long time. And so the new piece of data here would be the Angus Australia database. I think it's also interesting here to mention that, of course, we talk about the collaboration across the three countries and the associations, but even within the American Angus Association, there is a very strong collaboration that goes on to put something like this together, and that is between the information systems team and, of course, the AGI team. So the IS infrastructure is vital to make a project like this happen, both from a research standpoint, but also from utilizing the data and making the genetic evaluation happen every week. As we talk about adding phenotypes, and you hear from us all the time about the power of the value that adding new phenotypes and more data to the genetic evaluations have. And so here we wanted to go over some of the traits to give you a perspective about how much data are we talking about and how much data we're going to add into those genetic evaluations. We're not going to cover all the traits here, but we'll hit some of the major ones to give you a perspective. So for example, here on the slide, I have the winning weight in those evaluations, and here in this pie chart, you can see I have three colors in there. So in blue, you will see the US animals that are already in that evaluation, as well as in orange, you see the Canadian data also in that evaluation. So as we look into that third piece of the pie in green, we see the Australian animals that are going into this evaluation now. And as you can see, we're adding about 1.2 million winning weight records into that evaluation. For a next example, we can look into the heifer Cavanese records. Again, here the colors represent the countries, and you can see we're adding 260,000 Cavanese records from Angus Australia. As we look on a percentage basis, this represents about a 10% increase in the number of winning weight and Cavanese phenotypes that will be coming into this genetic evaluation. I think this is really exciting because it's a lot of data to be adding into the genetic evaluation, and that for sure adds a lot of power when we talk about predicting EPDs on those cattle. Next, we have our carcass traits. Here I'm representing those by the carcass weight phenotypes, and here I'm talking about carcass weight actual carcass phenotypes, which you can see from Angus Australia will be adding a little over 9,000 records on top of the 130,000 records that we currently have. And of course, for those carcass evaluations, the ultrasound records are very important as well to support that genetic evaluation, and here we'll be adding 460,000 ultrasound records from Angus Australia. So if we look from a percentage standpoint, we're going to be adding 6% of actual carcass phenotypes, and then a 17% increase in the number of ultrasound phenotypes that will be adding to that genetic evaluation. I think it's important to point out here as well that the Angus Australia has a strong structured sire evaluation program on their side, and I think this is very important for us, especially as we move forward. We'll get that high quality data into those genetic evaluations from Angus Australia as well. Now, we talked a bit about how much data is in there and how good is combining all those data steps, but I wanted to give you guys an overview, and this is not meant to cover everything or all the steps that we did on the research phase of this project, but we wanted to talk a little bit about some of the important boxes that we need to check before we combine the data for a genetic evaluation like this. And the first important point here is we have to have connectivity between those populations, because it's one thing to have those databases siloed in different countries, but it's another thing to have actual strong ties and connections between those data points to be able to improve our predictions. Of course, here we're talking about pedigree connections as US sires get used in Canada or Australia, but we're also talking about genomic ties. As we get genotyped animals into those populations, genomics help us connect them even more. Another important point is we need to make sure, as we get those phenotypes together, that the phenotyping or the data recording follows similar guidelines and scoring procedures, both from a standardization point but also from a data quality standpoint. We know that here in the States, the US breeders put a lot of effort in collecting high quality data and submitting that to the association. And so we want to make sure that when we include partners into this project, that they have the same high standards for data recording and reporting as well. And of course, this is the case for both the Canadian Angus Association and the Angus Australia. Another point here, and this is where maybe we spend a lot of the time from the research perspective, is we need to be able to account for management differences. Of course, we do this within country, but also now even more we need to do that across countries. And so that's why that information about contemporary groups and age and sex is so vital here, because we need to make sure we can model those differences as we combine those data sources. Along those lines, we also need to make sure that the traits that we're combining, we are targeting the same traits at the genetic level, that we're selecting for the same things. And so again, like I mentioned, a lot of the research time was spent here to make sure we can combine the data sets and we can properly model those differences to be able to combine the animals and evaluate them together. One of the things that when we talk about the connection between those populations, we can look into the pedigrees, of course. And as we look into those pedigrees, we can see the number of sires that we have being used in Canada or Australia from the US is a relatively small number of sires when we look at it from an overall perspective. And you can think of this as, of course, it's tricky to export semen or export an animal to a different country, and so the overall number of individuals flowing is not necessarily very large. But what's important is once they do go across the pond, let's say, how much progeny of how many descendants do they leave into those populations. And so to get a little bit into this, what we did was, here in this graph I have a representation of all the Australian progeny in the growth evaluation, or the Australian animals. You can see there we'll have about 1.6 million animals in that evaluation. And on the bar, you can see on the green portion of the bars here, what I have is, you can see about 80% of those individuals, of those progeny, they are sired by an Australian sire. And as we think about this a little bit, it makes perfect sense, right? That most of the progeny, most of the animals in Australia are progeny of an Australian sire. But what gets really exciting is when you look into that blue portion of that bar, you will see that about 20% of those individuals are actually sired by a US sire. So that's really exciting when we talk about connecting the population and the influence that those animals will have once they get over there. Now, this is looking at the relationship between sire and progeny directly. We're not looking into grandsire or great-grandsires. And so over generations, as animals get used in Australia, or this is true for Canada as well, they will have more influence in the population, leaving their descendants. As we look here on the right-hand side, we have the Canadian progeny now, and it paints a very similar picture where 77% of the Canadian individuals in that evaluation are sired by a Canadian sire, and then about 23% of those individuals are sired by an US sire, which is very exciting. It's reassuring for us that those populations are connected and we can bring those data points together. Another really important point here as we talk about connections is genomics. With the genotyped animals, especially in the more recent years, that helps us bring those populations closer together. And we'll be also adding the genotypes from Angus Australia. So if you look at this pie chart now, I'm representing the number of genotyped animals in the population. So currently in the genetic evaluation, we have about 1.4 million genotyped animals. And as you can see, we're going to be adding 260,000 genotyped animals from Angus Australia. And so that will push us from 1.4 to about 1.6 million genotyped animals on that weekly genetic evaluation. One important point here, as we use a single-step genomic blob for the genetic evaluation, we know that we use both the pedigrees and the genomic relationships to create even stronger ties between those databases and those records. And so that's why genomics plays an important role here as we talk about connecting those data resources. Another thing that we can do, and of course on the research side, there's many things we can do with the data like this and with the genotype database like that. But here I wanted to show an example when we can look into the population structure a little bit using the genotypes on those individuals. This graph here is the principal component analysis graph that is showing basically the genomic relationships between those populations as we put them together. The colors here represent each country. So in blue we have the Angus Australian animals, in green we have the Canadian animals, and in black we have the US animals. As we look through these graphs, we can see there's a big overlap between those three populations of animals, which means we have very strong ties between those populations. So it's one more thing that we can use the genomic data to be able to combine and study those populations a little bit more. Now, as we shift gears a little bit in the presentation, we wanted to leave you guys with some results as well. What we're going to do here, we're going to go over some of the results from the latest research run of the World Angus Evaluation as we wrapped up the final stages of the research process. And we'll look into two groups of results basically. At first, we're going to look into all the AAA registered animals. And this serves to help us understand on the macro level what's going on with the genetic evaluation and what kind of changes do we see or we do not see. And then on the second part, we're going to look into more specific groups of sires because we know that there are some groups of sires that will have more influence from a genetic evaluation like this as they get progeny added from Angus Australia. So here, if we think about the sires in the sire evaluation report, we're going to look at current sires, main sires, and the supplement sires. This again will give us a little bit more detail as we review changes and look into correlations. The first set of results, again, like I mentioned, we're going to look this from a macro level overall the whole population. Again, I'm not showing results from all the traits, but I picked a few to serve as examples here as we look into these results. We're looking at yearling weight, weaning weight, carcass weight, and marbling. And here, I know there's a lot of data in this table, but we're going to go through it a little bit. The column on the far right-hand side, you can see is the correlation between those EPDs. And what this correlation is basically the correlation of the EPDs without the Australian data and the EPDs with the Australian data. So you can see in there for the evaluation column, I have the World Angus Evaluation and the AAA NCE weekly evaluation. As you can see, those correlations are very high across the board, over 0.99, and this replicates to the other traits as well, which is good. We always like to see those high correlations on those individuals. And then as we look into the distribution of the EPDs, that is the averages, the mean, the max, and the standard deviations, we also see a very small variation on the overall distribution of the EPDs. So that tells us that there's, on the overall population, there's minimal changes in EPD ranking. That means we're going to see very small changes in how those animals are ranking. And then there's only small changes in the overall distribution of those EPDs in the population. Now, of course, we wanted to see some more of those specific groups of sires. Again, there are some individuals that will bring more progeny than others, and so they are more susceptible to change. And so for this graph, I'm also showing the correlations between the EPDs with and without the Australian data. But here I'm showing for all the traits, as you can see on the x-axis of this graph. And the colors on the bars here represent, for the blue color, we have the current sire. The orange colors, we have the main sires. And then in gray, we have the supplement sires. As you can see, overall we have very high correlations across the board on all those traits and all those groups of sires, but we do have some smaller correlations. So for instance, if we look into the milk, the Cavanese direct, and the carcass weight EPDs, we have correlations of 0.98 for those groups of sires. And as we look into Cavanese maternal and fat, we have correlations of 0.96 and 0.97. Again, overall very high correlations, but we will see a little bit more change on those individuals when we look into the EPDs and the accuracies. What I did here is a very similar table as we had before, but the traits that I pulled were those ones where we had the lowest correlations for the current sires. And so for us to look at the correlations, but also looking into the distribution of those EPDs. As we look across those traits, even at a lower correlations, we can see that the averages, the standard deviations, the minimum and the maximum of those EPDs remain relatively constant, which means we're not seeing big shifts on that genetic evaluation. Rather, those changes are more on individual animals, and the overall evaluation remains very consistent, even when the correlations are slightly lower. Now, when we talk about those changes, and even in those cases where we have a little bit lower correlations, we need to talk about what are the different data sources that are affecting those EPDs. And as we talk about bringing in pedigrees, phenotypes, and genotypes from Angus Australia, of course the changes we'll see on the EPDs in accuracy, they become clear as we investigate them a little bit further. So the first one here, of course, is progeny records. Think of this as if you're adding data on an individual animal here in the States on a given week, adding progeny phenotype is going to move that EPD most likely, as well as the accuracy. And so in this case, it's the same reasoning. We're bringing additional data into those individual animals, but the data is coming in from Angus Australia. So progeny record is probably the first source of potential change in EPDs and accuracies that we'll see. Another interesting point here is when we talk about the genotypes, there are some US sires that they don't have a genotype here at the American Angus Association, but when they go over into Australia, they do have a genotype over there in their database. And so we're bringing that genotype into the genetic evaluation now. And of course, we might see changes in EPDs and accuracy because of that. We also have the addition of genotyped progeny that could lead into some of those changes. And then records from relatives. Of course, it's easy for us to think from a perspective of, okay, I'm adding progeny records to that sire, and that's going to change potentially the EPDs and the accuracy. But if I'm adding those progeny that will affect a grandsire or a great-grandsire, those changes could trickle down and affect younger individuals as well. So it's important to keep that in mind. Here to give us a perspective, okay, how much progeny data is there? So I took for the growth traits, so birth weight, weaning weights, and yearling weights, and basically for that group of current sires, I looked into how many progeny records they are adding in the World Angus Evaluation. As you can see, for birth weight, we're adding almost 190,000 progeny records. For weaning weights, we're adding a little over 150,000, and for yearling weights, we're adding a little over 100,000 progeny records. And so it's a lot of records, right? And those are the changes that we're expected to see on EPDs and increases in accuracy as well as a result of adding those records. Now, when we talk about those changes, they are all due to adding new data into the genetic evaluation. So everything pretty much remains the same. The weekly evaluation remains the same, the models, the genetic parameters, and we're just adding the additional data from Angus Australia. And so as we think about this, there are many American bulls, as we've showed throughout the presentation so far, that have been used in Canada or have been used in Australia, and now those bulls are bringing additional progeny records from there into the database. So if you think about from a genetic evaluation standpoint, adding those extra records on different herds from a different herd book allows us to better describe the genetic merit of those individuals, and potentially that will lead into an increase in EPD accuracy by adding those progeny records and the genotypes. One important thing to mention here is that, of course, when we think about adding data, it's easy to see the changes on a young animal because I'm adding new progeny. But we need to keep in mind that for this particular update, we might see changes in even older animals as well. And the reason for this is because we're not just bringing the data on young animals from Angus Australia, we're bringing all the data, and so all the historical data that maybe there was a US bull that was very popular in Australia maybe 15, 20, 30 years ago. Well, those progeny records are coming into the evaluation now, and so we could see some changes on those individuals as well. Now, another interesting point that we have here is we're adding a lot more data as we've covered so far, but one interesting aspect of this is that all this data is being added at once into the genetic evaluation. Of course, the US members and the Canadian Angus Association members do report a lot of data into the genetic evaluation every year, but that data is spread out across the weeks throughout the year. Now, what we're doing with this one, all the data is coming in at the same time from Angus Australia. And so what I did is I went back to our weekly reports and I took an average of, okay, how many weaning weight records we add on a weekly basis, how many Cavanese records we add on a weekly basis, and how many genotypes we add on a weekly basis. And I'm comparing here on this graph with the amount of data that we're adding from Angus Australia at once this week. As we look into weaning weights, for example, we've seen before we're adding 1.2 million weaning weights from Angus Australia. And as you can see here on the average, or rather it's very hard to see the bar because of the scale of the graph, we're adding about 3,000 records, 3,000 weaning weight records on a weekly basis. Now, this average is just about 2 months worth of data, so throughout the year this could vary a little bit, but it gives us a perspective of the amount of data that we're adding at once. As we're looking into Cavanese, we're adding 260,000 records from Angus Australia, and then on a weekly basis, we typically add 2,000, a little over 2,000 records. When we talk about genotypes, again, we're adding about 260,000 genotyped animals from Angus Australia, and we add on a weekly basis 3,700. So my point with this graph is we're adding a lot more data at once compared to a weekly genetic evaluation. And as we talk about those correlations between the EPDs, on a week-to-week basis, our correlations here for our genetic evaluations are 0.99 across all the traits that we evaluate. And we saw that for the World Angus Evaluation here, for some groups of sires, for example, those current sires, we saw some correlations that were 0.96 and above. So even though we're adding a ton of data, the correlations are still pretty high. But of course, we'll see some individual changes as those animals get progeny records added into their predictions. As we get ready to wrap up the presentation here today, so this World Angus Evaluation expansion goes live on Friday, October the 13th. What's happening there is we're adding Angus Australian data to 11 more traits to that World Angus Evaluation. This World Angus Evaluation will help us better describe and connect Angus genetics across the globe, especially as we talk about the databases from the American Angus Association, the Canadian Angus Association, and Angus Australia. And I think this is really exciting because this is really the first step as we foster that collaboration with those three groups, and as well as the international commerce of individuals and exchange of genetics globally. Before we finish up, I do want to touch on one more tool that we'll have available for the breeders. Here, of course, we're talking about the genetic evaluation on the EPDs. For the US breeders and the Canadian breeders, everything is going to be pretty much the same as far as how you look into EPDs and how do you search your results. But there will be an additional tool that is the World Angus Evaluation Sire Search tool. So for the American breeders, this will be very similar to the EPD search that you can use today for the AAA animals. Of course, this sire search tool was developed by our internal IS team, so that's why the resemblance of the two search tools. But basically here, as you can see, you'll be able to search for individual animals from the three databases, from the three associations, for all the 13 traits that we'll have on this World Angus Evaluation. And finally here for my last slide, I did want to bring up here that this World Angus Evaluation now encompasses 13 traits. They are all listed in here, and as we overview the genetic evaluation, so we'll have data from the three associations for our growth evaluation, for our Cavanese evaluations, carcass, as well as the ultrasound data, the scrotal circumference, and the foot score that has been there since 2020. And so with that, I wanted to invite Kelly here to the stage so that we can have some discussion on this topic as well.
Well, perfect. Well, great job, Andre. I think this is going to be a really exciting time come Friday for our membership. You've been working on this one for quite some time, and the whole team has been a pretty big lift. Yeah, and it's been an exciting project. Again, like I mentioned, it's exciting when you put all those three associations together. It's nice to jump on a call and have some discussion and talk about some exciting research. One of the things, Kelly, that we didn't talk about here as we talk about adding those databases together and compiling this genetic evaluation is, okay, typically we do changes in the genetic evaluation around that May, June time frame. Why are we doing this update now instead of waiting until that season? Yeah, I think that's a great question. It's a question that we had a long discussion in the boardroom about as well. And talking with that breed improvement committee, this has been one where we've always said once it's ready, we want to get the information into the hands of the American Angus Association membership as well as the Angus members in Canada and in Australia. And I think one of the things that really propelled the board and the staff to really make the decision to go forward with this one at a time where it's probably a little bit busier in the sales season than what we would normally like to see, is the fact that we're just adding data to this evaluation. Like you said, it's a lot of data all at once, and so it does re-rank some of our animals, especially those with not as many records here in the States as maybe they collected in Australia. But at the end of the day, we wanted to make sure that the membership had the tool available with this added data, so as we're going through the rest of fall breeding season and spring breeding season and producers are trying to make their bull selection decisions, that they had the most accurate tools available. And I think at that point, from that standpoint, we would never hold data out from an individual member in the US or Canada just because it was going to create some change for some individual bulls. And so we really felt it was probably the most responsible thing to do to get this one in and allow the members to start to take some utility from it. Yeah, if the data is there, why hold it back? Yeah. But on that note, we talk about, obviously, we run that AGI evaluation and the AAA evaluation on a weekly basis. Canada's data comes in monthly. We're dumping in a lot of data this time. So with the Australian data, how often is that going to come in? From that standpoint, are we going to just dump this data in 1 or 2 times a year, or how's that going to work? Yeah, so of course right now we're going to add that bunch of data at once, right? Because this is the initial step on that process, but everything is set up so that once this is rolling, we're going to get the Australian data on a bi-weekly basis for the genetic evaluation. So we have great collaboration with the IS team, that very well as well. They help us with the infrastructure, right? So that on a weekly basis we get the AAA data, and then on a monthly basis we'll get the Canadian data, and then on a bi-weekly basis we'll have the Australian data flowing in, and it will be business as usual. That's awesome. I think they call it fortnightly, not biweekly, right? Right, that's right. But from that standpoint, you talked a little bit about having standardized measurements, and I think, birth weight, weaning weight, even calving ease, we have the same scoring systems. Obviously, you can only take the birth weight at one point in time, but we know that Australian Angus and just the Australian beef industry is on a little bit different scale when it comes to our carcass data. Right. Specifically the marbling. Can you talk to us a little bit about what you had to do with those actual marbling scores from Angus Australia in order to make sure that they're compatible with the data we had here? Yeah, I think that was a very important step, right? First, we need to make sure all the data is combined properly and that is compatible. I think there was even research done prior to ours, right? Of course, they wouldn't have the USDA grading system in there, but to make sure that, okay, there is some equivalence between those two basically grid-based systems. So in the US is the USDA, and then for their system in Angus Australia, so to establish some kind of correspondence between the two scoring systems so that we make sure that we're evaluating the animals on the same basis. Sure. Yeah. So we had to do a little bit of standardization of our own based on that prior research that was done. Yeah, for sure. And if you think about even more basic than that, if you think about the growth traits, the weaning weights, for example, they measure things in kilograms where we use pounds, right, in the data. And so it might seem like a small detail, but it's a very important one, right? That we need to make sure that those scales match and the data is compatible across all the animals and traits. Sure.
So maybe one last question for you, and this goes for all genetic evaluations. So we talked about, obviously, this collaboration. It creates a global currency, right? A common currency between our three associations. The International Exchange of Genetics, the World Angus Evaluation will become American Angus Association's evaluation, will become Canadian Angus Association's evaluation. And all of that is right and good, but one of the other reasons we're really interested in that is just the sheer number of records. We know data is expensive to collect. We know it takes time. We know that we have to have high quality data for good genetic evaluations. Talk to us just a little bit about why that was so important to us to increase the quality and the growth of our database, and why it continues to remain important to increase the number of phenotypic records when we're in this age of genomics, right? Why is it so important to continue to grow those numbers?
Yeah, I think as we talk about genetic evaluations, right, we've seen a lot of technologies come in place as we talk about ranking animals based on genetic merit. But I think one thing that hasn't changed, right, is the importance of phenotypic records. And so that's why we talk about collecting data. Every time that we get a chance, right, we're talking about we need more data, we need to expand that. And so in a collaboration like this, of course, that given that the populations are connected, there are exchange of genetics, you can see the links between the pedigrees and the genotypes, right? It makes a lot of sense to bring that additional data. And if you recall on one of the graphs, right, comparing how much data we're adding now versus how much data we add on a weekly basis, it takes a lot of weeks to record that same amount of records, right? And so if we have those synergies, why not incorporating all that data? For sure, it adds a lot of valuable from an EPD accuracy standpoint, but also from a genetic research standpoint, it gives us a lot of power to do a lot of interesting things as well.
Yeah, well, that's excellent. Well, maybe we'll take some questions from the audience now, and hopefully Friday goes off without a hitch.
Yeah, awesome.
Thanks, Andre.
Thank you.
All right, so thank you, Dr. Andre Garcia. Obviously, we taped that yesterday afternoon, and so had that one pre-recorded for this evening. But now we're going to get into some of the live questions that we have received from some of our members out there listening to us on the webinar. And the first question, which I think is obviously a very important question, is will this change data collection or reporting procedures for association members?
Yeah, that's a very good and important question, right, Kelly? And I mean, as you think about the data reporting and the data recording here in the US, right, all the procedures and guidelines will stay the same. I think a lot of the research that we did initially when we talked about this World Angus evaluation is, okay, are those things being measured in a similar way? Can we account for the difference that exists through our statistical models, so that we can keep the data recording procedures the same, right? And so for the US breeders, everything remains the same, and the guidelines and around data collection will remain pretty much the same.
Yeah, so definitely for American members and Canadian members, data procedures are going to remain the same. Even for the Australian members who may be looking at this genetic evaluation, they're going to remain the same. But I think an important thing to note, right, Andre, is not every single data record from Angus Australia may be able to come into the World Angus Evaluation, because if you're collecting a weight at 600 days of age or something like that, that may be out of scope of the data edits that we have. There were some of those records that obviously got omitted at that time. Is that correct?
Yeah, for sure. And there's a lot of quality control steps, right, between getting the data here, the raw data, and actually running the genetic evaluation. So both from a modeling standpoint, but even before then, what data are we actually letting it into the evaluation, right? We need to make sure that everybody follows the same, data quality control standards, so that we keep the evaluation as good as it can be, for sure.
Yeah. So all those data quality procedures we have built into that, the current weekly genetic evaluation, are going to remain true, and we'll continue to clean that data as it comes in and only put the best data in there.
Yes, and everybody's pretty much running through the same pipeline, right? So regardless if it's the AAA data, is Canadian data or Australian data, the quality control parameters and kind of pipelines that we have in place will be the same for all the data going through the evaluation.
Great. Next question, kind of along the same lines, but obviously talking a little bit about data security. So when we talk about sharing the association data, let's focus on the American Association data here. What data security measures were taken?
Yeah, I think that's a very important question. And as I mentioned in the presentation, we get to be the host of this, right? And so we appreciate the trust and the confidence that the Canadian Angus Association and Angus Australia have in us. to be able to be the host and run the evaluations. But I think that's why the IS infrastructure is so important, right? The information systems teams, because of course they have much more knowledge about data security procedures and what we do from a software and even hardware standpoint to protect the data and make sure that we have, backups and safety around those databases. So from my standpoint, I'm glad that we have that team to help us build that infrastructure, right? Because they know much more about data security and those things than we do on the animal breeding side of this equation.
Yeah, absolutely. So really no American Angus data is gonna leave the database infrastructure that's here, that our IS team is able to put security measures around. And then obviously we'll handle that Australian and Canadian data with a high degree of security that we place on our own data as well.
Exactly.
So this is kind of a little bit of a bigger picture question. Are you aware of any other breeds or groups that may have something similar to this, or maybe working in a kind of a multi country network like this?
Yeah, that's an interesting question, Kelly. And I'm not sure about here in the US, and you of course you have a lot of knowledge on this topic too, so feel free to chime in. We know that there are some other international groups that do this kind of collaborations, right? Maybe some we could maybe cite the example of the Interbull
Sure.
with some of their beef or the dairy evaluations, but I don't think here in the States we have an initiative like that, not that I'm aware of.
Yeah, and maybe we have the group from IGS, right, with that collaborative network with that multi-breed population. Yeah. I know that they bring in some data from other countries. Also, one of the people just in Kansas City, the American Charolais Association and the Canadian Charolais Association, they have a joint run, and so there's a few out there probably from that standpoint. But I think that's one thing where from an Angus standpoint, this is kind of the one that we're involved in.
Right.
So from there, one of the questions in here is obviously Canada and Australia, when we look specifically at the growth database or maybe the carcass database, you had your pie charts up there, and obviously the US data is a big part of that puzzle, is a big part of that pie. As far as a collaborative effort, do you kind of talk to the value of putting those databases together? Because I think it can look like, well, maybe these other groups are getting more value from the US database than maybe we're able to garner from the Canadian and Australian database. And I know you touched specifically on maybe some of those harder to measure traits like the carcass traits earlier.
Yeah, I think, of course, when you look into the database that we already have here between the US and Canada, right, that's a huge database of phenotypes already. But I think there is some benefits, especially I specifically mentioned the structure SAR evaluation that Angus Australia has to collect carcass data, actual carcass phenotypes. And we know those data points are very hard to collect. And so having a partner like that with a program that is established as well to collect those carcass phenotypes will be beneficial for the US individuals as well. And if you think about even in a more individualized basis, right, for those individuals that do have progeny in Australia, there will be benefits. We'll get an increase in accuracy on those EPDs as we add those extra phenotypes in the evaluation for sure.
Yeah, because some of those bulls that are used in Australia, some of those are the same popular bulls that are used here in the US. Other bulls that are US natives that are used in the Australian database maybe weren't as highly used here in the US. And so from that standpoint, we might be characterizing some specific genetic lines a little bit more readily because of the fact that, they didn't get picked up here in the US, but they got used pretty highly in that system in Australia.
Exactly.
From that standpoint, here, I'm just reading my next question here. So when it comes to the $B and $C indexes, or maybe we'll just kind of blanket it and talk about all of our indexes, right? What will be the impact on those $B and $C indexes?
Yeah, and as we talk about the indexes, in this case, is specifically for the U.S. animals, right, that we're predicting those numbers on. There's no changes in the actual indexes, but the changes that we might see on the dollar values, right, are going to be a function of changes in EPDs. And so as we look across changes in the individual animals, we see, some EPDs will go down, some EPDs will go up as a result of adding new data, as we usually see. And of course, that will be, embedded into the calculation of the dollar value indexes, and so that could play a role in changing the dollar values. But basically, those changes that we might see will be a function of the changes in the individual EPD components of those indexes.
Yeah, so we're not really changing any way that we include data into our indexes. We see those high correlations of 0.96 or above for those indexes as well, or excuse me, for the individual EPDs. So we'll see similar correlations for the indexes. And I think when you look across the board, the average EPDs from last week to this week aren't changing a lot, which would probably lead us to believe, and we know that the average $B and $C values in the population aren't gonna change all that much either.
Mm-hmm, exactly.
So looking forward, Andre, what's next? More traits, different EPDs, indexes, more countries? What do you think the next step is, maybe as we look beyond what's going to happen on Friday?
Yeah, I think that's an exciting question. And as far as, especially within this collaboration, of course, we're expanding now. It's a big step going from, just a foot score evaluation to now, adding a few more traits into that mix. We have talked about some maybe additional traits. For example, we talked about maybe heifer pregnancy or mature weight or docility records that Angus Australia captures. Of course, as we go into some of those other traits, again, we have to evaluate how those things are measured, when they are measured, and how compatible they really are. And so there are some traits that are easier than others to investigate on those, right? But I think as far as traits, there is some opportunity maybe to explore some other traits as we move forward and as we do more research on the evaluations that are going live on Friday. As far as more countries, right, I think that's also an interesting question and perspective for the future. I think the key point here would be, if we do entertain taking other partners, right, we need to make sure that they also follow the same, quality procedures to record the data, the same data quality standards, and they follow similar guidelines as, the three associations that we have combined now, so that we make sure everybody plays by similar rules, and make sure that the data quality we can ensure that the data is from good quality sources, no matter the case, right?
Yeah, good data partners and good association partners overall, just to make sure that we keep that genetic evaluation the best it can be. So, yeah. But maybe some opportunity, especially with some traits that may be a little bit more low labor recorded, or some lower heritability traits, heifer pregnancy, feed intakes, and things like that, I think could potentially be a really good data resource to put together.
Yeah, and especially I think you mentioned feed intake now. I think especially on traits that are hard to measure, right? That maybe each individual association has a relatively small data size, but when you combine them together, right, it brings more power to that evaluation. So there could be real benefits to, especially on those traits that are lowly heritable or that are more expensive to collect data on, for sure.
Yeah. So this one's a little bit about the reporting of the EPDs. Obviously, we're moving into this, what we're calling the World Angus Evaluation environment for these 11 traits, in addition to the foot score and claw set that have already been there. So talk to us a little bit about, will that change our percentile ranks on our EPDs, or anything to that extent, Andre?
Yeah, so I think as far as the reporting goes, right, everything will be fairly similar for the US breeders and the Canadian breeders. And I think one additional piece that we talked a little bit about was that international sire search, right? And so we'll be able to search some animals on that kind of list of individuals, but for the US breeders and Canadian breeders, they will get their EPDs updated and will be able to look up animals online as well, as as they currently do now when the current evaluations.
Perfect. One of the questions here, and this one is kind of diving back into our foot score evaluation that we've had around for a little bit. And obviously that's not a new trait we're putting in this environment, but Australia, while they have the same scoring system, actually the American system was kind of mirrored off of that system that had been present in Angus Australia and in the Australian cattle industry for about 10 years prior to us bringing it on. They do still use some independent evaluators on foot scores. And so one of the questions that was basically asked was, what was the correlation between the AAA EPDs for foot EPDs compared to Angus Australia? And actually, that might be one. Maybe I'll just go ahead and take that one, Andre, is the fact that specifically for the foot score and claw set EPDs, that is a 3-trait combined, and in Angus Australia never had a foot score evaluation, or they transitioned to our evaluation at that time. They had a little bit different models, so to kind of go in and look at the rank correlations and some things like that probably gets a little tricky, because there was quite a bit of change when Angus Australia kind of transitioned away from their old model and into kind of this linear trait model that American Angus had at that time. So that one's probably a little bit hard to answer. But when we look across kind of the pond and those sorts of things, obviously based on, you know, forward validations and looking at progeny records and things like that, we do a really nice job combining those two data sets.
Mm-hmm.
With that, maybe we'll take just a couple more questions. And this one is talking a little bit about the PCA plot, that principal component plot that we have. As you look, the main change in the accuracies will be impacting the Australian population. That is, they might increase accuracies on bulls represented across country, but impacting negatively the Australian animals with no representation and different allele frequencies. Do you have any comments on that one?
So, and let me drive back to kind of that graph, right? And so I think that's one of the steps that we also did is, of course, we need to make sure on the genomic side, right, that the panels that we're using are similar. We're going to use the same marker set to predict all those animals. And so that PCA plot is one example of things that we can check, right? We can do some analysis on the genomic relationships across the 3 populations, but we can also look into allele frequencies and things like that. And those are very similar when you look across the different populations. But yeah, that's a good point. We can use the genomic data to check the compatibility between those populations and making sure that they are similar enough that it makes sense to combine the data. Of course, if you were to calculate allele frequencies across the 3 populations and they are drastically different for a lot of markers, right, that would be a red flag for us to think about a little bit more, because those populations would be maybe a little bit more divergent, which is not the case in those 3, right? They're all kind of Angus based. And again, those pedigree ties makes a difference. And of course, now with genomics, we can make that even stronger.
Perfect. Got a little highly technical question in there. Couldn't let you off the hook that easy, Andre. So
No, those are good.
From a dollar value standpoint, maybe we'll touch on this one, and then we'll kind of let people know where they can go for some more information after the release on Friday. Will each association still continue to report their own bioeconomic indexes, or will we actually combine them in a 3-trait, or excuse me, a 3-country type of environment?
Yeah, so for the indexes, again, like I mentioned before, as we talked a little bit about the dollar values, right? The dollar values would remain being the indexes for the US population. I think the Canadian Angus Association also have their own set of indexes. And so the indexes would still remain individualized from that perspective. Of course, the EPDs going in are from the same source, from the same database, but how the indexes are calculated, that will still remain individualized.
Yeah, and a lot of that has to do just with the differences in management, or the differences in the objectives within our 3 countries. Like we mentioned, you know, obviously we're only having USDA graders and kind of our grid premiums and those sorts of things here in this country. It's a little bit different in those other countries, so they'll remain separate so they can be the most useful to those individual breeders in those individual countries. So with that, if you guys on Friday have questions, be sure to look up some information. We'll have basically, if you check out the Angus Journal, the By the Numbers article and the Data Dive article here in the beginning of October contained information about this update. If you guys have questions about individual bulls, please reach out. Whether that's somebody here in AGI or our performance programs, our customer service representatives. You know, if you have questions, please ask. We're more than happy to walk through any of those answers and those sorts of things. And so feel free to call the office, email, text, however you normally communicate with us, and we're happy to answer those questions. So with that, we're out of time here, running up right against 8 o'clock. If we didn't answer your question and you still have them, email myself or Andre, and or the webinar link, and we'll certainly try to follow up with those individual questions. On behalf of the staff here at the American Angus Association, thank you all for joining us. Thank you, Andre, for sharing your wisdom and your knowledge and all your work on this particular project. We want to invite you to our next webinar that's going to be hosted on December 5th at 7 p.m. Central. The topic is going to be on a functional longevity research EPD. That has also been a big topic of conversation here at the American Angus Association for quite some time, and we sure hope that you'll join us for that webinar coming up here in December. After we finish, your browser will be redirected to a survey. We sure appreciate that feedback on that survey. We want to make sure that we're giving you all the right information and the right messages that you feel are necessary to basically allow us to continue to serve you, the American Angus Association membership, in the best way possible. Additionally, the full recording of this webinar will be available on Angus University at the AngusTV YouTube channel, and it will be sent to you via email. So if you didn't get enough of Andre tonight, you can watch him again on the recording of the recording, and certainly share it with your friends. So with that, once again, thanks for joining us. We appreciate you, and have a good night.